Okay, in 6.3 we started talking about parallelograms, and today we're going to start talking about special parallelograms. And those three special parallelograms that we're going to talk about include the rectangle, the rhombus, and the square. And I want you to remember that these are also parallelograms. So those 6 properties that we talked about parallelograms in the last couple days still relate to rectangles, rhombuses, and squares. So just to review, those 6 properties of a parallelogram. First of all, the definition of a parallelogram is that it has both sets of opposite sides are parallel. So that means in a rectangle, rhombus, and a square, both opposite sides will be parallel. Also, we know about parallelograms, both opposite sides are congruent. All right, so in all of these, this is going to get kind of jumbled. Okay, in all of these, we know that the opposite sides are parallel. Now we know that the opposite sides are congruent. So this side's congruent to this side, and this side's congruent to this side. We also know that one side, if it is parallel, one set of opposite sides are, are parallel and congruent, then you're going to have a parallelogram. So if you just know, if you don't know anything about these two sides, but you know that this one side of opposite sides are parallel and congruent, you will have a parallelogram. We also know about parallelograms that both opposite angles will be congruent. So this angle will be congruent to this angle, and this angle will be congruent to this angle in all the rectangle, rhombus, and the squares. We also know that consecutive angles are supplementary. So that means if I add up this angle and this angle, they're consecutive because they're right next to each other. If you add them up, they're going to equal 180 degrees. And the same thing over here. This angle and this angle are consecutive, so if you add them up, it'd be 180 degrees. And same for this angle, and same for this angle. And then the 6th thing we talked about for parallelograms, which also relate to the rectangle, rhombus, and square, is that the diagonals, diagonals bisect each other. So that means that if we look at this diagonal, it's going to be bisected or hit in the midpoint by this diagonal. So this side will be congruent to this side, and this part of the diagonal will be congruent to this part of the diagonal. So all these properties that we've talked about the last couple days also relate to the rectangle, rhombus, and the square. However, there's something additional about the rectangle, there's something additional about the rhombus, and there's something additional about the square that sets it apart from all other parallelograms, and that's why they're special. So let's talk about the rectangle first. The rectangle, if you look just at the rectangle, let's see if I can get a rectangle, a good rectangle for you guys. Boom. If you look at a rectangle, all those 6 things are true about, all those 6 properties of parallelograms are true. The other things that make it stand out, the definition of a rectangle, is that it has 4 congruent angles, which are 90 degrees. So this will be 90, this will be 90, this will be 90, and this will be 90. The other 2 things, that's the definition of a rectangle. That's what makes a rectangle a rectangle. There are 2 special properties about a rectangle. The first one is that the diagonals are congruent. So if you look at the diagonals, if you look at this one, it's going to be absolutely congruent to this one. And remember, we said that it's a parallelogram, right? So in parallelogram, the diagonals bisect each other. So that means this part's going to be congruent to this part, and this part's going to be congruent to this part. So that's something that's very special about a rectangle. That's it. Sorry, these are the only 2 properties, special things about a rectangle. They have all angles are 90 degrees, and the diagonals are congruent to each other. Okay, so that's the rectangle, super special. Next shape we're going to talk about is the rhombus. The rhombus, the definition of a rhombus and what makes it special from everything else is that it has all sides are congruent. Oh man, I don't want the rectangle anymore. All right, let's see if I can draw a rhombus. Nope, they don't have it for me. All right, I'm going to draw the rhombus like this. Okay, so in a rhombus, the definition of a rhombus and what makes it special is that all sides are congruent. So in a rectangle, all the angles are congruent. In a rhombus, all the sides are congruent. So I'm going to put tick marks right here. There are two other things that are special about a rhombus. The second thing that's special is that the diagonals are perpendicular. So if I look at the diagonals, I draw this one, and I draw this one, they are perpendicular. They always meet at right angles. So I want you to get in the habit of drawing these right angles whenever you see four congruent sides. And let's see, if we look at this picture, we have some congruent triangles in here, right? Let's see, we have a right triangle, and we know that the hypotenuse are all congruent, and they share a side, right? So these four triangles are going to be congruent by HL. At least this triangle will be congruent to this triangle, and this triangle will be congruent to this triangle. So if they're congruent to each other, that means that these angles are going to be congruent to each other by CPCTC. So if you look at it, oops, I don't know why I did that. Oh, sorry. Okay, so if we look at the congruent triangles, we have that this triangle will be congruent to this triangle, and this top triangle will be congruent to this bottom triangle. But it's also a parallelogram, and we know that in a parallelogram, that means that the opposite angles are going to be congruent to each other. So this angle and this angle are also going to be congruent. And if you look at what the diagonal is doing to these angles, it's bisecting the angles. So the third property is that the diagonals bisect the angles. And then the third special parallelogram is a square, and a square is the baby of the rectangle and the rhombus. So it has all the properties of a rectangle and all the properties of a rhombus, and it makes the square the most specialist parallelogram of them all. So some questions you're going to see on your homework tonight. The first ones are very, very basic. We're just using those properties. So this one, the important word that they say is a rectangle. So you know for a rectangle that what? We know that all right angles, and we know that the diagonals are congruent. Those are the properties on top of everything that we know about parallelograms. So if this one, they say JK is 50. If this one's 50, we know opposite sides are congruent, so this one will be 50. And I tell you JL, this whole diagonal, is 86. So that means that KM, the other diagonal, would also have to be 86. They want you to find HM. HM is only part of the diagonal, and remember for parallelograms, the diagonals bisect each other. So that means all you have to do is cut 86 in half, and your answer will be 43. All right. The first questions are very, very basic. Okay, so let's look at this one. Again, the key word, we're talking about a rectangle. They tell you that this part of the diagonal is LJ. So that means because the diagonals are congruent, this part will be 30.8, this part will be 30.8, this part will be 30.8, and this part will be 30.8. They want you to find HK. Notice HK is an entire diagonal. So what you're going to do is take 30.8 and multiply it by 2, and that'll get you your answer. All right. Let's see if there's any other ones. Let's hit this one. This one's really basic. This one they want you to find HJ. We know that that's an opposite side. Opposite sides are congruent since a parallelogram, so your answer would be 48. All right. Now we're getting to some rhombus questions. Rhombus. All right, so what do we know about a rhombus? We know that all the sides are congruent. We know that the diagonals are perpendicular. and we know that the diagonals bisect the angles. And again, it still has all the properties of a parallelogram. So we know that this is a right angle and this is a right angle. All these are right angles. We know that these sides are congruent to each other, and we know that this angle has to equal this angle. So let's just ignore the question for a second, and let's figure out everything we can figure out from this picture. Okay, so first, let's start off with the sides. We know all sides are congruent, so let's figure out how big the sides are. We know that 13b will have to be equal to 3b plus 4, and this side are all going to be the same. So to first sides, you set them equal to each other. 13b minus 9 equals 3b plus 4. Get the variables on the same side. So now we have 10b equals 13, and b is going to equal 1.3. And then this is not your final answer. Remember, the next thing you're going to have to do is plug it in, and that'll tell you how long the sides are. All right? Okay, so that's how we can figure out the side lengths. Let's see. To figure out what A equals, let's say we wanted to figure out what this angle is. Well, we know that this diagonal WT bisects the angle XTV. So we know that this part is going to be 5a minus 5, and this part is going to be 5a minus 5. But if we set those equal to each other, we're not going to get anything. This is not an equation that will help us. So we need to figure out how can we solve for A. And we have to look elsewhere. So the only other A in this picture is right here. And we know that this angle is going to be 90 degrees because the diagonals bisect each other. So the equation we're going to use instead is 14a plus 20 equals 90 degrees. And then solve from there. So 14a equals 70. A equals, divided by 14. A equals 5. And then you have to plug it in. Now, we already know that this angle is 90 degrees. We don't need to plug it in here. We want to figure out what this angle is. So 5 times 5 minus 5 will get us 20 degrees. So this angle will be 20 degrees. Now let's fill in everything we know. This angle is 20 degrees. So what does this angle have to be? 20 degrees. Now we know this whole angle is 40 degrees. So what does this whole angle have to be? 40 degrees, because opposite angles are congruent. Now what do we know about consecutive angles? They are supplementary. So if this whole angle is 40 degrees, what does this whole angle have to be? It'd have to be 140 degrees. And remember, the diagonals bisect the angles. So that means this one would have to be 70, and this one would have to be 70. And the opposite angles are congruent, so these ones would also have to be 70. See all that information we can find now about the rhombus? So awesome. All right. So why don't you to try to figure out how to do this problem. Okay, they tell you it's a rhombus. So again, about a rhombus, we know all the sides are congruent. We know that the diagonals are perpendicular, and we know that the angles are going to be bisected. All right, so here's everything we know about a rhombus. Okay, they said we want to find GCH. GCH, that's this one. We want to find this angle right here. And we know if we can find this angle, or this whole angle, all we have to do is cut it in half, right? Okay, so let's see what information they give us. They tell us GCD, that's this whole angle, sweet, is B plus 3. So our game plan, if we can find measure of angle GCD, then cut it in half, we can find measure of angle GCH. Okay, so in order to find GCD, we need to first solve for B. So let's see how we can solve for B. The other information they gave us is that angle CDF. CDF, that's this whole angle right here, is 6B minus 40 degrees. All right, so if we look at this whole picture, I know there's a lot of writing on it, but if we look at angle C and angle D, they're not opposite angles, they're consecutive angles. So we know that consecutive angles add up to be 180 degrees. So we could say b plus 3 plus 6b minus 40 equals 180. So now we can combine like terms, and we have 7b minus 37 equals 180. Solve for b, and we get, let's see, what is that going to be? 17? I can't remember. 180 plus 37. Boom, 217 divided by 7. So we get b equals 31. Okay, that was our first step, solve for b. Remember, our game plan is to find what measure of angle GCD is. So now GCD is b plus 3. So 31 plus 3 is 34 degrees. So we know this whole angle is 34 degrees. And we know that the diagonals bisect the angles. So 34 degrees divided by 2 will get us our measure of angle GCH, and that is 17 degrees. Nice job. All right, I'm going to show you how to verify properties of squares in the next video.